going to go ahead and get started. The fun part is I've got this divided room, so if we start a war between the two sides, it's invisible to me. And also, I'll note, so I can see hands raised over here if I'm standing over here. If I'm standing over here, I can see hands raised, but it doesn't alternatively work on the other side. So feel free to cough loudly or say my name. It's Jess, and I want to make sure we do get questions throughout the event. How many are familiar with Sysdig? Awesome. Actually, okay. Had to double check. So I'm a day-to-day systems administrator, and Sysdig is a very powerful tool. I'm not necessarily associated with the project, but I just think it's so nice, so useful, so versatile that I wanted to get up here and share this thing that I've discovered. So let's start with this question: what do you do when something breaks? Reboot. Excellent answer. The sole Windows admin in the room. So what do we do when something breaks? I'm sorry? You acknowledge the page, you get up at 3 a.m., you acknowledge the page, and you start investigating. You're looking at the problem, but you might have a clue, you may not have a clue. Thank you for rebooting. I actually do like that answer. I was expecting to hear Google, actually. That's a very common, useful strategy. But it's not the sole strategy. And as sysadmins, and I'm speaking from my own experience here, I think there's much better ways of exploring problems. And I like talking about this because guessing and just Googling is not always the best approach. It can make it worse, absolutely. You go in, you make your change, all of a sudden you've now made your 15 different changes in your environment, and who knows if what you then fixed is really the issue that you first had. Who needs a changing environment? So instead of just guessing or validating, let's look and see what we have. And as a Linux admin, what I really love about the Linux kernel and open source projects is they do their darndest to make sure that the information is in my hands to troubleshoot something. I like Sysdig because it takes all that stuff a step further. So as a general approach, we have a theory of what's going on. And maybe this is correct. Maybe it's not. Through our exploration process, we will use tools to verify whether or not what we think is happening is happening. Google works in a lot of instances. But what a lot of admins don't do is Google a problem, verify that it's actually their problem, and then proceed with the troubleshooting on that page. So that's an important step. As a simple example, right, this is my basic diagram of I'm troubleshooting a DHCP issue here. The DHCP server is not on my local subnetwork. Instead, I've got IP helper on a gateway. This is a network device. I don't control it. Good for you guys that I don't control the network devices. But I've got the node making a request, gets passed through the IP helper, DHCP responds, it comes back, but it never hits my node. So this is a very recent problem that I had. And how did I troubleshoot it? Well, first off, I happen to know quite a bit about DHCP. But if I don't, there's Wikipedia, there's lots of resources out there to figure out what a DHCP request should look like. And then I used a tool, TCP dump. And this shows me exactly what's on the wire. It shows me what's on the wire from the node perspective. It shows me what's on the wire from the DHCP server's perspective. And what's even better, what I really like about TCP dump is that it records these traces to a file. It's very nice. Because then it's not about am I having the issue now? It's what happened when the issue occurred. Did I get a capture of that? So can we do that for processes? And that's my intro. Let's talk about Sysdig. Hopefully that's why you're all here. Sysdig does give us the reading and writing. Again, you've got the cheat sheets in front of you. They're up here. Feel free to grab some more after the presentation. But again, we just turn it on, Sysdig-W. We record what's happening on the system. We reread it later with Sysdig-R, and we can even do some compression to make sure that we don't fill up our 120 gig drives. Gentleman in the front row here was messing around with that. He was actually recording X activity and filled up his whole system in 6 minutes. So glad you have fun with the tool. It can be dangerous. But that's Linux for you. More than enough rope to hang yourself. So the important lesson here is, can we recreate the bug? Yes, because every system support technician is going to ask you this question, and now all of a sudden you have a trace file. So we've got a trace file of something happening. Let's pretend Apache is failing to start. What can we do? Well, we record our Sysdig capture. We try it out. It doesn't work. We close our capture. And then we go on. We start using Sysdig to investigate what's going on. Sysdig has two components. It does require a kernel module to start dumping information. Once that's been written to a file, of course, the file is your ownership by whoever has it, so anyone can reread this stuff later. So the sudo right at the beginning is an error on my part. I really should have gotten rid of that. However, we're reading the file. We say, give us everything that happens with Apache, and just give me event failures, right? Let's just ask a very simple question of what's going on during this trace. Well, we follow this output down. All of a sudden, right here on the bottom line, hey, my address is in use. So as a sysadmin, our port is in use. What do? Nets -- NTLP. Got this memorized. I've been a sysadmin for some time. But we have versatility. We have other tools for this. Let's just ask Sysdig. Sysdig comes up with an answer as well. A very nice answer. And more importantly, it's the answer from the time we were having the issue. Things change all the time on their systems. Maybe it was a fluke. But here, no, we can definitively say at the same time we started Apache, Netcat was listening to the port. So this was a contrived example, but it starts to illustrate the power of having this stuff recorded at a point in time. So some basics, filtering. The possible fields we'll go through, the operators are simple. We have Boolean operators as well for and or. The cheat sheets in front of you have quite a list of the Sysdig fields, but just going through an overview of what we have. We have file descriptors. So any file activity, we can look at file descriptor by number. We can look at file descriptor by name, directory that it's in. Again, because everything is a file on Unix systems, we have source ports, IP's address, also reachable as files. We have procs, kind of obvious, so we can search by PIDs, names, arguments if we want to. Event number is an internal field within Sysdig for when we're running through the trace. Every event actually gets assigned a number, so we can actually narrow that down on later use. Raw times, system times, arguments for the calls, and also if we want to select on users or groups or even syslog activity is an integrated feature. So as a best practice, when you're writing your filters, use lots of quotes. It's very easy to get confusing errors because of the matching patterns. We're going to talk about chisels in a second, but we also encapsulate our chisel parameters in quotes, and the reason why it's right here, right? So why is this going to bomb? Anybody familiar with Bash? Why is this going to bomb? Exactly. We don't want to do that because it's going to be read as an input redirection. Instead, encapsulated, Bash doesn't care at that point. It's now passed as part of the string, and boom, that filter is going to work for you. Here, we're actually using a chisel, and we've got double quotes around proc name equals NC. We're passing that to the chisel. We're passing the event number 310 outside of that. But that's not going to work well for us. It's actually going to complain because the entire double quoted string proc name equals NC is passed to the chisel. It's actually going to interpret that as 3 different parameters to its argument. So that's going to cause you confusion. You're going to bang your head on the table until you figure out that it's really telling you that you have too many parameters. And so I'm trying to drill that into your head to remember that little point. So what are these chisels? They're prepackaged functionality within Sysdig. It's very easy to add your own, very easy to pass these around. It uses the same filtering syntax as Sysdig itself, and if you want to see a list of them for possibilities, you can look at that as well. And here we have a list. We've got spectrogram and top proc CPU for CPU usage. We've got files, file descriptors. So if we want to look at I/O, we can filter for just standard error or standard out events. Log activity, net activity, LSOF, performance, a whole bunch of different things, right? Security, we've even got shell shock detect if you want to use that. Spy users, that sounds fun. Wonder what that does. And, oh, hey, look. Even got P outlooks. So, chisels, let's start looking at those. LSOF, what do we think LSOF does? Thank you. Participation, or excuse me, that's my portion of the presentation that includes audience participation. So LSOF, it lists open files. Right here, we're filtering for MySQL events. Specifically, we give it an event number. We do that because the Sysdig capture, part of the magic of it is, at load time, it captures the entire system state. It's very useful. Part of the system state are running processes. And then as the trace happens, it updates the table, the internal allocation table, within Sysdig of events as they're going on. It's not constantly rereading the system. It's just doing the maintenance work of keeping that up to date. So if we don't pass at a point in time, I want to say the default behavior is to give you, if you're not passing a filter, it's going to give you the state of the system at the end of the trace. If you pass it a filter, it's going to give you the state of the system when it matches that filter. So by specifically calling out event.num equal 1, that's the time we're getting, because that's the first event that matches. So here, proc name equals nc. We want to look at event time equal num. Event, all the events in our trace file are numbered. So the first event, LSOF at that time, if we're filtering for NC, it says, hey, this is what exists, and this is what it has at that point in time. If we don't use the event number, again, it's at the end of the capture, and for this particular capture, by the time the capture ends at event number 3477, LSOF, or NC has died. So we're not only recording the events that's happening in the system, we can reference them by point in time to see changes. So I was talking about the internal system state. And then way early in the talk, I said one of the things that I love about Linux and open source in general is that it wants you to have as much information as possible. So where is all this information coming from? /proc. Linux wants you to know about this. Is it necessarily easy to dive through? Yes, no, depending on your comfort level of all this other stuff. But there's a man page that's going to happily tell you about all the individual entries. Read it. It's very useful stuff. Likewise, procnet TCP gives you the events in the TCP, the open TCP ports and connections. So if you're listening or established, boom, there you go. So as a specific example, the file descriptors for the MySQL process on January 30th, when this when this slide was made, we can see that it had a couple libraries open. A couple database file tables open out of MyY, MyD, whatever, and then it goes on from there. That's truncated. So we're starting to see some functionality here that is useful, because point in time is never something we get from LSOF. We have to purposely dump that into a file if we want to do anything like that. But are we really replacing LSOF? No. Sysdig is a tool. But one thing that Sysdig doesn't do well is this very short one-liner right here. LSOF plus L1 gives you a link count of all the files on the system that actually have 0 links, less than 1. These are files that were created and then deleted, but are still in use because some process is pointing at them. Why would someone do this? Because they're trying to hide files from you. Sysdig could recreate that state if you're specifically looking for that. But again, it's kind of hard to beat 8 characters, including the space, to figure out exactly what's going on. So as much as I'm enthusiastic about Sysdig, as much as it's a great versatile tool, it's not the end-all be-all, and it definitely has room for improvement. So the PS chisel, process table. Again, it has the same point-in-time stuff. So right now I've given an example of what the PS state is at the end of my capture, but if you want to change that, add the event number or some other search to figure out what that is. Be patient when you're messing with that because it can be quite tricky to figure out what you're looking at when. Where's it getting all this stuff? Again, procfd. This is just the description from the man page. That's what you're getting at that point in time. Netstat, we have a netstat filter. This is not listing the routing table, which we normally use netstat for. It's listing the open files. So IP addresses where it's, or excuse me, point numbers where it's listening, established connections, and there we go. Sysdig came from the background of a system tracer tool. The LSOF, PS, netstat functionality, it's very easy. I bring this up first because as sysadmin, it's what I do. It's accessible. These are the commands I've used all the time. I use on a daily basis. I don't necessarily reach for strace a whole lot. But Sysdig, coming from that background, gives you that functionality as well. I do occasionally reach for strace. How many people are comfortable with strace? Excellent. Mic right in the room. So strace is giving you that SCaLE information that's happening in the process. What is a SCaLE? For those people who didn't raise their hands. We have our userland binaries. We have the kernel actually acting as a mediator for all the system resources. And so when our user space process wants to get something done, it asks the kernel very nicely, do this for me. Depending on your permissions, all this other stuff, it'll complete this. A different description of system calls. Again, the man page is very helpful. But just some common syscalls: open, close for files, read or write for information in and out of those files. Fork exec is a new process spawn. So if we're using exec calls and we're watching those and recording those for all our times and events, all our user activity is going on in the system. So again, I noted the spy chisel earlier, or excuse me, spy users chisel earlier. Here we've got an example of it. Just a simple command line. We've got a trace. Hey, what did users type in while this file was being executed? That last parameter there is the depth that we want to go to. So if they ran a bash script that actually called in subprocesses, it'll nest for us. So very nice. So in this particular chisel, it's the same example that I had earlier. I opened up the netcat for my contrived example, tried to start Apache. Oh, look, it failed. And that's the extent of it. Likewise, a very useful one we are going to reach for time and again, is the echo file descriptors chisel. And this reaches into those system calls and starts dumping the buffer output. Pro tip, when you're using echo FDS, /R. Otherwise, we're going to be seeing lots of anti-escape codes, which I don't read natively. I have not reached the master of the matrix, so I don't read those natively. So again, a very simple example. Echo the file descriptors for MySQL. Here we've got some process going on in the background. Sysdig recorded it. What happened for MySQL? We had MySQL snip, database connection, enter your password. Oh, password 01. So says your friendly security officer, aha, but they don't have usernames. In fact, they do. Again, because we've recorded the file, it's very easy. Call outs by users. This is the exact user. It's a vagrant user. They entered the command, and so right there on the command line, they passed in root, and again, they typed it in later. So early feedback said I need to make this more interactive because while I appreciate some of the power of the root passwords, we're going to try a little bit interactive, and I never like those because they never go off exactly as you want them. So questions or comments or even cheers or encouragement when it works well, feel free to belt them out. Okay. Please.
So one of the things I work on a lot is embedded systems with very limited amount of writable storage on the device. Is it possible to pipe the output of Sysdig through a socket to another place?
Absolutely. So thank you for asking that question. The question was, is it possible to output the dump of Sysdig from your local system to another system? Yes, absolutely. It's a Unix process. Just pass in a remote file socket, NC, whatever. It'll do that. At the end of my slides, I actually have other resources. There's a security use case, which I particularly love. When I found out about Sysdig, I actually just discovered it on my Mac, which is kind of funny since it's a Linux tool. But they make the binary, the reader, available on multiple systems, so you can take the trace files and replay them anywhere. So I saw it on my Mac, said, what is this? Started looking it up, found Sysdig.com. On their website, they have some blog posts about interesting use cases that they've done. And what struck me, the power of it, was in the first blog post I read. It was finding hackers with Sysdig. They spun up an AWS machine, well, they said unnamed vendor, but they spun up an AWS machine. Maybe it was Rackspace. I don't know. I'm just guessing. But they spun up this machine instance, set the root password to password. You thought password only was weak? No, they set it to password, and they waited. And they were actually dumping the Sysdig output to an S3 bucket. So they waited. And I forget the exact times they quoted in the article. I think it was like 40 minutes, whatever. And so all this system activity is just going on in the background. They didn't turn on anything in the system. It's just very low level going along. And then all of a sudden, spike. What's happened, right? Knock, 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 SSH, root, password. Hey, I'm in. So what do? Well, at that point, they let it go on for just a little bit, but for responsibility, they canceled it after that. And then they've got their Sysdig trace in the S3 bucket. They've downloaded it to their local system, and they start looking. Spy users. These are the commands. The hacker, whatever. I guess I don't like that term, but the hacker. These are the commands he typed in as soon as he got on the system. These are the files he uploaded to the system as soon as he got on the system. This is the tar-gz. This is what he got out of the tar-gz. And they're pulling it all from the buffer space of the system capture. It's a great read. It's a great example. Yes, you can absolutely dump your system file somewhere else. I'm not affiliated with the company. I'll also invite you to look at Sysdig Cloud, because they actually use the Sysdig agent as a, I don't want to say monitoring endpoint. Sysdig Cloud, the enterprise SCaLE, is that now all of a sudden they've got Sysdig agents all in your hypervisor environment or your container environment. They dump it all back. Just the IO stats, not necessarily the file descriptors and whatnot. Excuse me, not necessarily the buffer activity and whatnot. But then they start a monitoring platform on top of it by watching the individual machines. And it's pretty impressive stuff.
Just a follow-up question, obviously.
Yes.
Does Sysdig output include its own activity?
Yes. Sysdig's output does include its own activity. Likewise, Sysdig outputs include SSH, if you've SSH in the machine, as I have, with Vagrant. Likewise, it includes screen activity, like I'm using right now in my example. So it gets everything, so it's going to be big trace files. Be aware of that. But also, the recorded nature of it, it captures everything. So be careful in your filters. If you do a raw dump of everything, you're going to see everything. But also, because we have this file, we can go back to it in time and again, and we can ask a very specific question and open that up later. So yes, it's going to be a fire hose, but you can also start small and expand outward. And also, with the use of the chisels and whatnot, it's a very interactive process, so you can start somewhere, figure out, ask a different question, or come at it from a completely different angle and move on from there. Question in the back. I don't have numbers on, excuse me. Yeah, so the question was, am I going to touch on performance overhead? I'm not going to touch on performance overhead. I'm not. I've not had any instability with the kernel modules. I know the developers are very conscious of the performance overhead. I don't have the exact numbers in head. It's, I think the rule of thumb is strace adds like an order of magnitude at least factor overhead. I think they quote 2 to 4, but run your own numbers. I don't have those. Any more hands? Thank you. The question was, in my examples, I'm only filtering after the fact. Can I instead pre-filter into my trace files? No, that functionality is not available. The gentleman in the back of the room mentioned he hadn't heard of this tool. Development, I think, has been ongoing for about a year and a half. They first started releasing blog posts, I think it's June of last year, somewhere in that time frame. So it's a very new tool. It's very active in its development. They just finished up a lot of development for container support. That's not officially released. That'll be in the 0.1.97 release, which is estimated for 2 to 3 weeks. So keep a lookout for that, because again, going back to, you've got one agent on a machine that has 15 containers on it. You're not watching from inside the individual containers. You're watching from the host. So nobody knows they're being watched, but you're also seeing across those container boundaries. So very active development. No, there's not pre-filtering right now. If that's a feature, it's on GitHub. Make a feature request. I see lots of utility in that feature and would not see too many issues on implementing that, except, well, I'm not the product developer, so I guess I shouldn't speak for them. Okay, pipes. Ba-bum, tux. It's a Linux con. So if Sysdig is watching all the system activity for us, it can watch across our pipes. Day to day, I build up some stupid one-liners, and probably redundant because I cat before grep and all that other stupid stuff. But here, the question is, can we see what's happening inside a chain? And how do we know about error statuses inside of our chain? So here, I've got a Word file. I use awk, print the number before it, sort it, reverse sort, pick the top one, print that out, have tux spell it out for me. So wait a minute, we just zoological, now it's zodiacal. Why is there a difference? Well, first off, I explicitly have an error generator in my pipe. It's real stupid simple. All right, randomly, 20% chance of failure of just exiting before it goes on to the next line. So my entire Word file, yes, I'm still reading in, counting up the characters, but then I'm cutting it out. But can we see that in action? So here I have a Sysdig request. -A says, give it to me in ANSI. -S says, give me 4K of the buffer. And then I'm using the echo file descriptor chisel. And now it's going to dump that onto the screen for me. I'm looking specifically for type or file descriptors that are pipes and reads only. I can do both, read, write, but I'm actually doing this for color reasons, right? The write output is in blue. I figured the red had better contrast. But again, I'm seeing the reads into the individual pipes. Okay, so here we see a failure attempt. Okay, so right at the start, hey, error.pl, what it read from its pipe was the complete list of words. Then it passes on whatever to sort. By the time we get to sort, we only have 4 words. And of course, head then receives a list of 4 words. It's got the number right in front. And zodiacal picks up the top. And then CalSay goes ahead and reads from the pipe and inputs it out. So again, how do we know that there's been an error in our pipe? If we just look at the command line, hey, we got back results, so we're going to automatically assume it's good. But we don't know that's the case. We can reach for Sysdig, look at the output and trace that down, or actually even look at because we don't actually have a SysCall failure. See, this is why ambition in a live demo is not a good thing. But likewise, we did actually have a failure, and so Sysdig would actually show us the output. We could walk through systematically to troubleshoot our process if we're not getting the results we want. Does the system actually tell us that we've got an error? Actually, it does. Does anyone know how Bash tells us that we had an error in our pipes? Echo $1. $ question mark. Back of the room. Boom. Great answer. I was going to demonstrate. Question mark, right. That's only the status. $ question mark is only the status of the last command. Pipe status is an array, and it tells us all the events. So we can specifically see that of our entire pipe, yeah, the second one actually errored out on us. And I discussed that because, again, I mean, I love Linux. Gives us many ways of looking at things. Sysdig actually gives us the actual step-by-step. Gives us the step-by-step file descriptors of what's actually going through the pipe. But again, Bash, if we just rely on it, hey, it told us we had an error as well. I personally think that's a little bit less useful, but at least I know and can follow up later. Question in the back of the room. I was going to resize the window. Thank you very much. But yeah, pipe status. There we go. Oh. Lost my cursor. Okay, there we go. So, second example. I know we don't have just sysadmins in the room. We've got some web developers as well. So a LAMP stack. As a sysadmin, I'm often asked to look at LAMP stacks, but web developers are great. Maybe this is a shared use case for us. So the question was, will it work at all without the kernel module? The Sysdig binary reads traces without the kernel modules. If you actually want something out of the kernel, yes, you need the kernel module. Correct. So let's step back and just say, okay, we have a LAMP stack trace. We have no user activity during this trace. We do have information going in and out of our system during this trace. Do we have bacon. So again, a simple WordPress blog post going through. There's actually a pretty nice lorem ipsum generator for bacon. So, you know, it's great. So anyways, can we actually see inside the application and what it's doing with our tool? And yes, we can. A different way to ask this question, well, not, Excuse me. A little more useful question during this is, so I'm asking what Apache touched, and then what did Apache read from? The dash P is just an output filter. I only care about file names. What file names did Apache read from during this event? And it read from the network. Great. Not exactly what I wanted. Let's see if we can change that. And fd type equal file. During this trace, Apache read from proc meminfo. Interesting. Read from user share zone info. It read from our themes. And here the idea is that, yes, we can actually follow along with our LAMP stack in action as it's doing stuff. And if we ever have any questions about what files it's reaching for when, right? Is it actually pulling from my theme directory or someone else's? Is it pulling from someone else's plugin directory, or is it even touching the right place? There we go. We can start to ask those questions and get meaningful answers about what it's doing. Question?
So if I was following strace and I was looking at open, I would see like an enoint for a file I didn't find.
Yes.
Can you get the result of what was the result of that request for that file in Sysdig? Like, can I say, like, yes, user share zone info zone.tab. What was there then? Is there a different response for I didn't find the file but I did look for it?
Yes. So the question, I believe so. Let me rephrase. So the question was, strace gives you enoint and other output of whether or not it found the file or whether it did not find the file. And the question was, does Sysdig do the same? Absolutely. Enoint just happens to be the kernel's response to having to look for the file. And Sysdig happily reports on everything that it finds. I specifically filtered for file names. But let's just step back, and the example was zone tab. Absolutely. And FD name contains tab. So I don't have any specific read failures. I'm not sure I have an example of that. We can dig around later. But here we actually see, yes, file descriptor 12 was pulled. Here's its name. The size of the file, 4096. So yeah, we absolutely have access to all the information that the kernel gives us. Question? Stat? Excellent. So actually, there you go. As an example, we did event failed equal true. And here we see the enoints. Thank you, sir. Yes.
So one thing I've, and maybe someone in the room can correct me, like with strace, you get the file descriptor, and once you catch the open, like while you're doing it, you have to go look up the file descriptor, like in proc.
Absolutely.
And so here I see it's actually doing a file descriptor, and then next to it, it's checkpointing what that file was at that point. File descriptor's changed.
Yes.
So like if I did an strace on something over time, and then looked at file descriptors, it may be different than what it was when I was looking at it.
Yes.
This seems like it's capturing it on
Exactly.
doing it.
And so
benefit over strace for like, so at DreamWorks we're troubleshooting our renderer of
okay.
6,000 machines, but that was changing very quickly. And so without building a separate thing to like checkpoint file descriptors,
Yes.
this seems like that solves our problem for us of like maintain the linking of the file descriptor to file name as you're doing this, putting the file descriptor and the name in those logs.
Absolutely. Again, as part of the trace, when it starts writing it out to the file, it dumps the current, pretty much proc directory, not all of it, but pretty much current proc directory, which is all the open file descriptors at the start of the trace. And then as it goes through, it keeps that state table, thread table it's called, it keeps it up to date with changing events. So if you link more files or unlink files, a little bit tricky on that because if you're searching by file name, it's a little bit tricky because then all of a sudden it's happening underneath different names. But if you are looking, I'm not sure you can specifically search on INO numbers, but that would be a thing. Actually, there is an open ticket specifically on querying on INO numbers now. So yeah, I would expect that to happen very soon. But yes, absolutely, you're seeing point in time as it's happening, file descriptor output. Question, back of the room.
Has anybody been crazy enough to send all this stuff to like centralized logging for security auditing or anything like that?
The question was, has anyone been crazy enough to try and set up a centralized logging service? I'm not aware of anything. As I mentioned, the enterprise product is doing some performance analysis with this information. Again, I'm not aware of anything. It would be completely possible, again, just because of the hacker example mentioned before. But I would be very, very cautious about doing something like that, again, just because passwords in the clear, we're reading directly off the buffer as it's going to the terminal, so all sorts of crazy information there. But yeah, very useful. Set that up and let us know your performance results. And actually, that's a very important point. And the gentleman asked about, is there a way to filter trace files? No, there's not. Excuse me, is there a way to filter the recording of trace files? No, there's not. So if you're having fun with a trace and you say, hey, go look at this, be careful about the contents of the trace. If you've done it on a system with lots of other users, who knows what they've put in.
One option for what I ended up doing for filtering my own captures.
Yes.
I just type the output. I'll do it. I'll watch it live instead of writing out to a file.
Yes.
I just watch it in the terminal and then just type it somewhere. And so I get the ASCII filters.
Yes, but you can't use Sysdig again to refilter.
No, I can't go back
yeah.
and change that filter. But if I know I want to watch something continuously.
If you think you've got it, absolutely. Yeah, the suggestion is, hey, just dump everything, the raw fields, just dump that to a text file, and then all of a sudden you can pass that around. Yes, that's absolutely one approach. It gets you 99% of the way there. My own personal inclination, very much dabbling in C and being very bad at it. I really do think pre-filtering is a good idea and want to get that worked on. But, questions? Okay. So one thing I'm not going to go deeply into are other uses. I've actually already mentioned the first one, or the second one here, the phishing for hackers. Again, I can't do it justice. Go read it. It's awesome watching it step by step. But then the other thing they do is spectrogram. This is a relatively new chisel. I think it was released at the beginning of January, if not mid-December. It's a very nice visualization provided by Brandon Gregg, I believe, about the latencies of system calls. So if you're doing performance troubleshooting, you can go in and actually start to mess around, and provides a very nice heat map of what's going on. Again, as a day-to-day sysadmin, I don't have to fine-tune performance to the scale that some other people do, but it's an interesting and accessible use case. Again, they're on GitHub, very open, friendly community. They're on IRC. I'm one of 4 people hanging out there, so ask your questions. I want to engage, but I'm not there 24/7, so be patient as you ask your questions. And then finally, there's also Google Groups. Any remaining questions? Yes.
One thing I have problems with S-trace is the good old full-text problem. What the hey is the thread that's tying up the stupid full-text to hang the whole program? Is there anything for tracking, like so you can track what the normal pattern is, who fell down when the program, multi-thread program is stuck?
There's a hot call. Please wait for stop time.
So the question was, the lady has some issues with futexes and figuring out what a baseline for those events are. And this gentleman pointed out that yes, there's a chisel for specifically recording top calls, and that may suit your needs. The other thing that I would mention,
It would be if you had test compiled for profiling on the system you're trying to debug.
that's not a use case I'm familiar with, first off, the few texts and tracking like that. Again, I don't do a lot of performance profiling on a day-to-day basis, so if somebody has better answers, again, let's start a discussion here. The other strategy, and maybe I'm completely off base with what you said, but just recording a normal period of activity would also serve as a great reference point. We could record, hey, listen, it's running great, it's been running great for the past 3 weeks, just take a quick trace of 10 minutes of activity or whatever is reasonable, and that gives you a reference point for searching in the future when you are seeing behavior that you don't necessarily like.
It has lower, you said it has lower overhead than your trace, right?
Yes. So mess around, your mileage and very please join in and send us results back, because I like tools, I like learning about tools, I like learning about different options and different use cases, so definitely would love to hear more. The TOPS calls was mentioned. I went ahead and pulled that up. Is that information that you were looking for, or is that completely off base? Completely off base. That's fine. As you can see, I did not seed the audience with people specifically to ask me questions. So there's a context for authenticity for you. Yes, questions?
Does Sysdig do anything with slash top and slash proc? Slash info, sorry.
Oh, I couldn't say. You'd have to check. The question was, does Sysdig do anything with slab info? Yeah. Again, couldn't answer that specifically with proc slash slab info. Are you just raising on his behalf? Excellent. Back to the room. So the question is Sysdig going to give you any insight of what is happening inside the JVM? It's not instrumented for that. It's instrumented for the Linux kernel. That being said, you can still track what the JVM is doing with the system kernel. So check around here. Questions? Thank you very much. I appreciate your time, and hopefully you guys are intrigued.